Here is a different solid sphere and a different solid cone. The formula for the surface area of the sphere is 4 pi r squared, and the curved area of the cone is pi rl. All measurements are in centimeters. The surface area of the sphere is equal to the total surface area of the cone. Find the ratio r to h and give your answer in the form 1 to the square root of n, where n is an integer. I'll first start off this question by looking at this sentence here and try to form an equation. So the sentence tells us that the surface area of the sphere, which is 4 pi r squared, is equal to the total surface area of the cone. Now, in this diagram, we are told that the curved area of the cone is pi rl. However, the cone has two surfaces, the curved part, but also the base. Now, the base here is a circle, and we should know that the area of a circle is pi r squared. So this is the equation I'm going to form, and I'm going to just try to rearrange this formula, this equation, and try to simplify. So if we look at all three terms, we can see that pi is the common factor. So we can divide all the terms by pi, and they just cancel out. So we are left with 4r squared equals rl plus r squared. Then again, if we look at all three terms, there is another common factor. It's r. So we can divide all the terms by r. When we do that, we get 4r is equal to l plus r. Then we can subtract r on both sides, and as these are like terms, 4r take away r will give us 3r equals l. Now, the ratio given in the question is r to h. We haven't used h yet. So let's decide what is h and how we can use it. So if we go to this cone, h is the height, and it's the perpendicular height here that forms a right angle with the radius. We can now see a right angle triangle, and we can use Pythagoras' theorem to find what L equals. So for Pythagoras' theorem, a squared plus b squared equals c squared. A and b are your two shorter sides, and c is your hypotenuse, the longer side. So if we use Pythagoras' theorem, we should get h squared plus r squared equals l squared. Now we know from the previous line here that L equals 3r. So I can substitute L as 3r, replace the L with 3r. So this gives me h squared plus r squared equals, in brackets, 3r squared. So all I've done is replace this L with 3r. Again, if I just keep going, so h squared plus r squared equals, now 3 squared is 9, and r squared, it's just r squared. So I've got h squared plus r squared equals 9r squared. I can subtract r squared on both sides. So I'm just going to go to the left now. So I've got h squared equals, now 9r squared take away r squared is 8r squared. And then final step is just to square root to get h on its own. So I've now got square root of 8r squared. Now this is just the square root of 8, and then the square root of r squared is just r, so it's root 8r. We're almost there. So then it says we need to just give our answer in the ratio 1 to the square root of m. So 1 is representing the r. So what we can do is substitute r as 1. R equals 1. So when r equals 1, what does h equal? So h equals the square root of 8 times 1, which is just the square root of 8. So h equals the square root of 8. Therefore, our answer is in the form 1 to the square root of n, 1 to the square root of 8. This is the final answer.